Okay, good evening, folks. My project name is Pivoted Document Length Normalization. First, we need to know about the basics. So, what is TF-IDF? In the information retrieval, the TF-IDF means term frequency inverse document frequency. It is a model helps us identify how much a word is in a particular document relative to a collection of documents. It's one of the foundational techniques used in search engines for ranking results, text mining, document similarity, natural language processing. Why do we need it? A simple count of word frequency does not work well. Common words like is, the, for appear frequently but are not informative. Longer documents naturally have higher term counts, which causes bias. TF-IDF balances this by scaling up rare terms and scaling down common terms. Understanding the TF-IDF mathematical formation. Here we were using the formula for the term frequency 1 plus log base of frequency Fij, and for the idea of log base of capital Ny Ni. Here Fij stands for frequency of term I in document J. Capital N stands for total number of documents. Ni stands for number of documents containing term I. TF measures term importance in a single document. IDF measures how rare the term in all is across all documents. The product gives the overall TF-IDF weight. The product gives the total TF-IDF weight. So here comes the problem. What is the problem? So document length bias. Although uh, although TF-IDF is powerful, it unintentionally favors longer documents. Example, a long document may repeat the same word several times. So if TF, which means term frequency, becomes higher, resulting in higher TF-IDF weight, even if the term is not proportionally more relevant. This is called document length bias. If we take an example, let's take two documents. Let's say the sentence in the document one is machine learning is amazing. In the document two, the sentence is machine learning is amazing and machine learning helps in data science because machine learning models from the data. Let's take a query term as machine. So let's do some calculations like in step one, we will identify the term frequencies and then we will compute the TF and then IDF and then we'll compute the TF-IDF. Here is the table of the TF-IDF for the documents D1 and D2. Here we can see for the document 1 the TF is 1 and IDF is 3.322 and the TF-IDF is 3.322, as well as for the document 2 the TF score is 2.5 and the IDF score is 3.322 and the TF-IDF score is 8.586. So what's the observation here? We can observe that there is a document length bias. Even though both documents talk about machine learning, the document, which is the longer document D2 gets a much higher TF-IDF, which means 8.586. We can see here 8.586 simply because it repeats the term three times. This shows document length bias, which means longer documents tend to have higher term frequencies and hence higher TF-IDF scores even if they are not proportionally more relevant. So what's the solution? The pivoted document length normalization. Simply we can call it as PDLN. So what's the intuition here? In traditional TF-IDF, documents that are longer tend to have higher term frequencies simply because they contain more words. This creates a length bias. Longer documents may appear more relevant than shorter ones, even when the shorter ones are more focused and relevant. A simple fix might be to divide term frequency by document length, but this can overcorrect unfairly, reducing scores for longer documents that genuinely contain relevant terms. Hence, the idea of pivoted document length normalization was introduced, a smarter way to normalize term frequency. Think of it as a soft correction instead of hard penalty. So let's come to the concept. If a document is longer than average, we slightly decrease its term weights because longer documents naturally repeat words more. If a document is shorter than average, we slightly increase its term weight since it has fewer words overall. And the pivot is done around the average document length, ensuring a balanced normalization that improves retrieval accuracy. Here comes the formula. Here the formula will be 1 plus log base 2 of Fij by 1 minus S plus S into DLJ by average document length. Here Fij stands for frequency of term I in document J. DLJ means length of document J, which means number of words or terms. Average AVG DL means average document length across all documents in the corpus. S means the slope parameter, typically between 0.2 and 0.8, and we usually take it as a 0.75 in most of the cases. So the final term weight will be normalized term frequency Ij multiplied by IDF of I, term I. So why it's called pivoted? The term pivoted comes from the idea that normalization is pivoted around the average document length. When document length of when document length of J document is equal to the average document length, normalization has no effect. No effect. When document length of document J is greater than the average document length, the denominator increases. So reducing the TF weight. When the DLJ is less than the average document length, the denominator decreases, increasing the TF weight. So the pivot point is the average document length, which keeps normalization balanced. If you take an example, here we have taken three documents. The text in the document one is information retrieval is powerful. The length of the document one is 4. And coming to the document 2, the text in the document 2 is information retrieval techniques improve information access. The length of the document 2 will be 6. And document 3, the text in the document 3 is information retrieval is a field of computer science that deals with searching and organizing large collections of information efficiently. Here the length for the document 3 is 15. We will focus on the term information, which means our query term will be the information. Let's see how each model, which means TF-IDF and PDLN, treats it. We will make sure we will calculate for both the models and we will make a difference among them, and we will get the differences among them. So in the step one, we will basically count Fij and the DLJ. So for the document one, frequency of information is 1 and document length for the document J is 4, as we have seen here. So frequency of information of the word information document 2 is 2 and for the document 3 it's 3. If we take the average document length, we have like document lengths of the three documents 4 plus 6 plus 15 by 3, which will be around 8.33. Let's take slope parameter as 0.75 and we have total number of capital N means total number of documents. Here we have three documents and number of documents containing the term information Ni equal to 3. So the TF-IDF calculation for here we have computed the TF-IDF for all the documents D1, D2, D3. Here the observation is TF-IDF says document 3 is greater than document 2 is greater than document 1, implying the longest document is most relevant just because it repeats the word more often. So according to TF-IDF, D3's weight is more than, D3 contains the information word more than the D2 and D1. So when it comes to PDLN, Pivoted Document Length Normalization calculation, here we calculated the formula and then finally we are getting the weights as for the document 1. We have got PDLN as 0.9, for the document 2 1.481 and for document 3 0.9948. Yeah, we have calculated using this formula. Yeah, here is the denominator part, and here is the normalized TF part, and here is the final converted part. Here is the result outcomes. So what is the comparison between the both two? For the document 1, the TF-IDF scored around 0.5 and the PDLN score 0.9 because document 1 is its size of document is very short. I think it's around 4. So short document boosted PDLN boosted the short document which is focused and concise to our query term. When it comes to document 2, its size of document is around 80, which means it comes in the medium category. So the TF-IDF scored around 1.170. So here it shows difference like document 2 contains information term more number of times than the document 1. But it is more relevant to document 1 than the document 2. But even it is more relevant to document 1. The score for the TF-IDF for the document 2 is 1.170. Here we can observe that PDLN score for the document 2 is 1.481. Why? Coming to the document 3, here the size of document is around 16. TF-IDF scored around 1.513 because of its length, and then PDLN scored around 0.948. Here it is penalized because long document it just contains the term repeating, so repeating term more times. And then when it comes to interpretation, TF-IDF bias D3 gets the highest score because it has more words and repeats information 3 times. It doesn't mean it's more relevant. It might just be verbose also. And when it comes to PDLN correction, D3's weight drops from 1.51 to 0.95 because it's much more than average. Here we can see 1.51 to 0.948 in the D3. So the reason is it is much longer than the average. Here we have seen the conditions, right? Yeah, yeah. When it is greater than the average document length, we reduce the TF weight. When it is less than the average document length, here it will increase the TF weight. When it's equal, the normalization has no effect. So that's why here the D3 is greater than the average document length, so that's why it's reduced to 0.95. Here, when it comes to D1, it is less than the average document length. That's why it's been increased from 0.58 to 0.96. Because and D2 remains fairly strong because its length is close to the average. That's why there is no normalization here. So what are the takeaways here? Pivoted document length normalization balances the scores, which means now D2, a focused medium length document ranks highest which aligns better with the human intuition. So PDLN is better because it recognizes that document length affects term frequency and adjusts accordingly. It prevents long repetitive documents from dominating such results, producing rankings that better reflect actual relevance instead of raw length.